Calorimetry by Nicole Mayers. All reactions have heat that goes in and heat that comes out. But how can we actually measure this heat? The answer is calorimetry. To measure calorimetry, you need to have three things. You need to use a well-known substance. This is usually water. You need to run the reaction in water to allow the heat exchange to happen in the water. And once you do that, you can measure the change in water temperature. The heat in the water, whether that be released from the water or taken in from the water, is going to equal the heat of the reaction. This is why we measure the temperature of the water. Now, how do you build a calorimeter? I'll show you. First, you need to start with an insulator. This can be just a generic styrofoam cup. What's even better is if you use 2 cups. Once you have the 2 cups, you need to fill this with water. This again is your well-known substance. Now that you have your water, you can add in your reactant. Usually this is going to be your acid. Now remember, you just stick a thermometer in there so you can measure the temperature. Next, you can add your other reactant. This is usually going to be your base. Make sure you add a stirring stick in there and stir it up. Now, our only job left is to watch the thermometer. So now that we see that our temperature went up and changed, this will be our change in temperature, or delta T. So now let's see how we can take that delta T and change it into the actual heat that was given or taken from a reaction. We're going to start with delta T again. We're going to do that and we're going to multiply it by C. This is your heat capacity. Then we're going to multiply by M, which is our mass, and this will equal Q. Q equals the heat lost or gained by the reaction. This is measured in joules. If Q is a positive number, that means that the reaction takes in heat and is therefore endothermic. But if your Q is negative, that means that the reaction gives off heat and is therefore exothermic. Calorimetry is very important. It measures the net energy loss or gain of a reaction and is necessary in our chemistry lab class.